All right, hey everyone. I already introduced myself. I'll do it again. I'm Vera. I lead comms, writing, external relations at Lattice. And today I want to talk to you about a world for NFTs. And world I use in both the world sense and also the mud sense of the word world that Andy was talking about earlier. And I will explain more. So today, let's talk about today and kind of the state of NFTs today. There are all of these standards around NFTs. The standards pretty much prioritize one thing, and that's ownership, figuring out who's transferring the NFT, figuring out how many NFTs you own. Those are all in the standards, and indexing events is then kind of all in reference to those standards, and then NFT platforms themselves kind of inherit those standards. So you get an environment that is kind of built around the core standard itself, but as our panelists were talking about earlier, all of these other cool properties of NFTs. They can be games, they can be SDKs, they can be APIs, they could be their own computer programs, The sort of design space for what an NFT can be is a lot larger, but the majority of projects just don't really get to enjoy that because they are kind of bound by what the core protocol is. So
enjoy this beautiful math castle GIF. It's actually not a GIF, it's a screen recording, because I couldn't figure out how to make a GIF. Secret there. So one example of kind of like a beyond ownership NFT or an NFT that kind of has properties beyond ownership are terraforms. They have all of these properties directly in the smart contract that kind of dictate different interesting things about them. It's completely on-chain. The contracts also contain metadata that situates the NFT collection actually within space with reference to other NFTs. So I think if we want to talk about like verbs other than to own, they're embodied and they can also actually change. There's like a dreaming contract, and if you use this contract, you can like sort of graffiti on your NFT or change it into something else. Another example, some of us have probably seen the 5 out of 9 chess, like the on-chain chess project where each move itself is an NFT. This is another example of like the NFT itself is a game. The verbs, to own, to progress, to play, you could say. And so what do these projects have in common? Well, they're on-chain, and most crucial, the NFT is this fundamental unit in this much larger kind of system that the NFT also kind of embodies. And why? Because they really evoked new verbs. They figured out things that you could do beyond own. And so NFTs should remind you that they're living on a giant computer, and they're kind of less fun when all they do is just kind of enshrine an economic zone. And so why don't we see more ambitious NFT projects? Probably answer number one is that it's just really expensive to make ambitious things. And we have this nice tweet from John Palmer talking about the Shields project and how expensive it was to deploy. It cost 27 ETH, so very expensive in 2022. And okay, yeah, sure, but like we're starting to see some ambitious things on L2s, but it's not there haven't really been anything that you kind of think to yourself, well, could this have been done on L1? So that's not so the answer to this question, I'm not totally satisfied by that. And so I think answer number 2 is maybe a little bit more likely. It's actually just difficult to build ambitious projects with vanilla solidity. And here's the shill part. Well, Mud fixes that. And I am going to tell you why. And we have all of these beautiful example projects, OPCraft, Skystrife, Words3, and Primodium. So ambitious NFT projects really do have game-like properties. So let's start building NFTs using Mud, which is, ostensibly a game engine, but just a ambitious on-chain application engine. And so Andy talked to you a little bit about this before. Mud gives you worlds. So sort of when you start out using Mud, you use store to kind of organize your files and your systems and your tables, but Mud gives you kind of this larger space in which to design. So you have this root world, and then you have different namespaces, and then you can have tables and systems in those namespaces. And basically the namespace, I'll talk a little bit. So namespaces are basically like teams. They're sort of ways of navigating how different teams, how different systems, how different tables interact with each other. Tables are the units of collaboration. Instead of siloing states inside contracts, not only exposing certain ways to read that state, all state on Mud is readable and queryable by anybody, but write access is limited within their namespace. So if you want to create, your own sort of enshrined universe within a Mud world, you would create a namespace and then, create your tables inside of that. Then systems, those are pieces of logic stored as EVM bytecode. So as you'll see, like tables is like state, systems are logic, and state and logic are separate. And so what are kind of the key aspects of world? Well, even though, you might have different namespaces across your world, everybody is going to share the same state. Everybody is going to use the same indexer and sort of understand everything that is happening in that world. You have permissionless extensibility. So, you might not be able to write to somebody else's namespace or tables within their namespace, but you will be able to build off of it, and you will be able to create new things that read from it. You have interoperability, and then you also have deep customization. So the world actually gives you kind of this layer between the Ethereum protocol and your smart contracts upon which you can kind of test out different EIPs, or even just introduce new rules that wouldn't be possible in the core Ethereum protocol, but you can kind of introduce as this secret juicy layer. So NFTs would probably benefit from these things. First, you have kind of the low-hanging fruit. You have a native indexer. So instead of having to write custom events, you just get an indexer for free, which is nice. And then that means marketplaces are easier to build, and any application that then kind of ingests all the data from emitted events, everything just kind of gets easier. But there's more exotic fruit. Think of World as an invitation to turn your NFT into a game. So, short digression, digital physics, what is that? Digital physics are kind of the genesis rules, the kind of the one most important rule that kind of resounds throughout the system and that everything is organized around. So the example that Ludens likes to give is kind of the digital physics of Ethereum is its state transition function. It is the fact that in order to do anything on Ethereum, you have to send ETH. And that is a very powerful thing. It actually kind of makes everything about ownership inherently. You have to own ETH. In order to make anything happen, in order to make things progress, you have to send money, and that actually does fundamentally make things about ownership, which is interesting. And so World kind of wants to ask, well, how can we kind of introduce these mitigations and these ways to make, other verbs and other kinds of interactions possible? So a genesis rule, which, you can think of as the digital physics, can introduce rules beyond what the Ethereum protocol already enforces. You could have in protocol account abstraction, which isn't really a Genesis rule, but kind of like a nice thing to have. You could have a CSR style mechanism, and I actually, shout out to Carlos, because you had oh, sorry, no, that's the next one. You have NFT creator attributions, ERC 7015, which Carlos had up on the EIP site. So yeah, you could have all these interesting introduction rules, but I think we'll get to like a much better and more concrete example later, a little bit later in the presentation. So why world? Like why use world over, you know, just deploying a different kind, like just an interesting NFT project that doesn't use world? Well, when you don't have a shared world, you can't assume anything about other projects and communities or even derivatives built on top of it. So you kind of get all of this siloing that happens between different projects, between different derivative works. I think we've probably seen this with a couple of projects. The only thing that you can assume is ownership. And MUD just makes it easier to build collaboratively if the interfaces exist across projects. The interfaces are read-write access. Okay, so let's go back to like the terraforms example. So imagine if terraforms were built on MUD. You have all of these interesting features already. You have levels, you have spatial coordinates, you have topography, and suddenly they have like all of these really interesting interactive consequences. So imagine like OP craft with terraforms, where the map reflects the terraform's terrain, its topography, spatial environment. And if terraforms were architected on MUD, maybe they would have designed it so you could write to the NFTs themselves and change the environment, change the NFTs. That would be possible. Or if you couldn't write to it, maybe just like the state and the world would periodically reset to the original state. You know, and you could have other emergent behaviors, guilds based on biomes or zones, new kinds of resource crafting. But still, we should be really specific and answer the exact question of like, why does MUD matter here? Couldn't you just, you know, create OP craft X terraforms and then deploy it kind of next to terraforms, read from their contracts, but not need to be in the same world? And the answer is you just get stronger digital physics if they're in the same world and stronger Genesis rules. So let's use a crazy example. Let's say you wanted your Genesis rule to be around the location of Terraform's contracts. And you want to actually say, you know what? Okay, I want people who are closer to certain coordinates in this world to have their transactions prioritized. And you could, you know, prioritize that based off of like their exact location on a map. And you could do that using like the interface that world gives you between the Ethereum protocol and your smart contracts. So basically, like the point is that digital physics gives you this like resonance across the stack and just like really incredible kind of abilities to kind of warp and play with Ethereum. And so all that is derived from the simple or maybe not so simple physics of the Terraforms project. Yeah, cool.